The sun is a giant nuclear furnace. Every second it releases more energy than humanity could ever imagine. Its surface is nearly 6,000 degrees Celsius, and deep inside its core, temperatures reach over 15 million degrees. So, here's the question that completely broke my brain. If the sun is that hot, why is space cold? Seriously, stand outside on a sunny day, and you can feel the sun warming your skin. Walk closer to a fire and you feel more heat. So, shouldn't all of space be unbelievably hot? Today, I'm leaving Earth to find out why space is cold, and the answer turns out to be far stranger than I expected. At first, I thought I already knew the answer. Maybe space is cold simply because it's far away from the sun. The farther you move from a heat source, the colder things become. Makes sense, except the more I thought about it, the less sense it made. Earth is almost 150 million kilometers from the sun, and still receives enough energy to power every ecosystem on the planet. Mercury is even closer and gets hot enough to melt some metals. Clearly, distance matters. But if distance were the whole story, then space near Earth shouldn't be cold at all. Yet somehow the temperature of space remains incredibly low. Something wasn't adding up. To answer the question properly, I decided to leave Earth. As my spacecraft climbed higher and higher, the atmosphere became thinner until it disappeared completely. Suddenly there were no clouds, no weather, and nothing standing between me and the sun. The sunlight was stronger than ever. The sun itself looked brighter than I had ever seen it from the ground. Yet outside my spacecraft was an environment so cold that most people would instantly assume they should be freezing. How can that be possible? How can you be surrounded by intense sunlight while floating through a region where the temperature of space is almost at absolute zero? The answer starts with a mistake almost everyone makes. We tend to think that sunlight and heat are the same thing. They're not. Heat is actually energy stored and transferred by particles. Molecules bump into each other. Atoms collide. Energy spreads through matter. But when I looked around in space, I realized something important. There were almost no particles at all. Space isn't filled with air. It isn't filled with warm gas. Most of it is an enormous vacuum. And if there are almost no atoms around, there are almost no particles available to hold thermal energy. Suddenly, the reason why space is cold started to become much clearer. Imagine opening an oven. The reason the heat rushes out toward you is because trillions upon trillions of hot air molecules are colliding with your skin. That's how heat usually works. But now imagine removing every air molecule from that oven. No gas, no atmosphere, nothing. The source of energy is still there, but there are no particles left to carry that heat around. That's essentially what a vacuum is. The vacuum of space doesn't behave like air because it isn't air. And that's one of the biggest clues to understanding why space is cold, despite being flooded with sunlight. At this point, I thought I had solved the mystery. Then I discovered something that made the whole situation even stranger. Astronauts can actually overheat in space. Wait, if the temperature of space is so low, shouldn't they be freezing instead? The answer is no. While space itself contains very little matter, the sun is still blasting enormous amounts of radiation in every direction. Without Earth's atmosphere protecting them, astronauts can absorb a huge amount of that energy. So they face two completely opposite dangers at the same time. Space is cold, but sunlight is intense. One side of your body can be heating up while the surrounding vacuum remains incredibly cold. This is where everything finally clicked for me. Sunlight doesn't heat empty space. It travels through empty space. That's a huge difference. The radiation leaves the sun and crosses millions or even billions of kilometers of vacuum without significantly warming the vacuum itself. The energy simply keeps moving until it hits something. A planet, a spacecraft, an astronaut, a moon. Only then can that energy be absorbed and turned into heat. That's why asking why is space cold leads to such a surprising answer. The sun isn't heating space. The sun is heating objects inside space. So, what is the actual temperature of space? If you travel far away from stars and galaxies, the average temperature of space is only about 2.7 Kelvin. That's just 2.7 degrees above absolute zero, the coldest temperature physically possible. What's even crazier is that this tiny amount of warmth doesn't come from the sun at all. It comes from the Big Bang. Nearly 14 billion years ago, the universe was unimaginably hot. As the universe expanded, that ancient radiation cooled and stretched. Today it still fills the cosmos as a faint glow known as the cosmic microwave background, and it determines the baseline temperature of space. To prove this to myself, I imagined placing two identical metal spheres in deep space. One sphere sits in complete darkness. The other is exposed directly to sunlight. The sphere in darkness becomes incredibly cold. The sphere in sunlight becomes extremely hot. Yet both are surrounded by exactly the same temperature of space. At first, that sounds impossible. How can two objects in the same environment have completely different temperatures? The answer is that the temperature of space and the temperature of an object are not the same thing. Once you understand that distinction, the entire mystery suddenly makes sense. So, after traveling into space and chasing this question to its source, I finally found the answer. Space is cold because space is almost empty. The sun doesn't heat the vacuum itself. Instead, sunlight carries energy across the vacuum until it strikes matter. That's why the temperature of space remains close to absolute zero even while stars burn throughout the universe. And the next time someone asks why space is cold if the sun is so hot, you'll know the answer. Sunlight heats things. It doesn't heat emptiness.